Today we're going to take a look at learning goal number 19, which is on evaluating problems involving powers. So this lesson is going to be taking a look at order of operations and how we incorporate powers into there, and what steps we need to finish first and how we can kind of work together. So it's going to be, again, mostly order of operations, but we're going to focus on the powers part of it. So let's do a little bit of review here. So a power is a number which is expressed using a base and an exponent. Powers can be solved when we using repeated multiplication. It's where we would take the base and we multiply it by the number of times the exponent tells us to. This gives us an answer which is in standard form. Okay, so it gives us an answer which is a standard form of the power. Now, standard form just represents that number which the power represents. Okay? It's the simplest form that we can put it into, and that would be standard form. Now, when we're using order of operations, powers, or what we might also consider to be exponents, are the second operation to be complete after we finish with our parentheses. Okay, so we first do parentheses, and then we do our powers or any of the exponents that we might see. Now, when solving a problem that has an exponent in there, we need to make sure that we solve the parentheses first, if there is any. We solve anything in parentheses first, and then we do the exponents. Okay, so first we do all the parentheses, and then we do the exponents. Now, in your assignments, as well as your assessments, I'm going to be expecting that you show all of your work. So when we just show your work with exponents, we solve each power individually. We solve each one individually. Once we have solved them, and then we solve. Then we solve for the answer using the remaining operations. And I'm going to be showing that in all of the examples, going through and specifically going each step showing the work that you have done. So very important that we show every single step and the work that we've done. So let's take a look at adding and subtracting powers. How do we do that? So when adding two powers together, we're going to solve each one individually first, and then we're going to add them together. So let's solve this statement right here. We have 4 squared and 3 squared. You'll notice that there are two powers. In this case here, we have the 4 squared first, and then we have the 3 squared after. Those two powers need to be solved first. So what we're going to be doing here is we're going to solve the 4 squared power. And we're going to turn on a little formula here. Okay, so 4 squared is the same as 16, and 3 squared is the same as 9. So we solve those powers first and put them back into the equation, the expression, exactly the way that they were originally. You'll notice I'm just going to draw a couple little lines here. So the 4 squared just becomes a 16, and the 3 squared becomes the 9. The plus sign and the equal sign stay exactly where they were originally. And so again, we're showing our work as to where we got those values from. The next step that we need to do is solve this addition. Okay, so solving this addition, we just do 16 plus 9, and that's going to give us, fairly straightforward, it's 25. So we put those together. So we're going to do the exact same thing with subtraction now. Now you'll notice here I've added in a little bit of bigger powers. Okay, if we're dealing with something squared, so something like our perfect squares that we're used to, you can do those without a calculator. But if we're dealing with something that's a little bit bigger, like a cube or even to the power of 4, that's going to be a little bit more difficult to do without a calculator. Okay, not impossible, but a little bit more difficult. So if you want to use a calculator for these, you can. But again, you need to be showing your work at every step of the way. So we're not just going to show the final answer. We're actually going to show the work that you're doing. 6 cubed. Okay, so if we do that on the calculator here, 6 to the power of 3 is 216. So this is going to be the same as 216. And 3 to the power of 4, 3 to the power of 4 is 81. This is 81. And so again, what we've done here is we have replaced each of the powers with its value in standard form. So we're replacing the values we're replacing the powers with the value in standard form. Okay, so that's the important thing to do first. Then we come through and we're going to solve for, now the last thing we have to do here is solve for the final answer, and that's just the operation here. Okay, so 216 minus 81. Some of you might be able to, again, do that without a calculator, but if you want, you can use a calculator. The answer is 135. So we show here that we got 135 as our final answer. Okay, so again, there's 3 different steps here. Or I guess 2 steps in this case here. We solve the powers. Okay, we show our answers when we solve the powers. Next step, now we're subtracting. In this case here, we solve the powers and then we added. So very important that we do those again in order. Now, when more than 2 powers are used, and I guess we could also say, we could consider this when more than 2 terms are used, we could say that as well. The same idea or process is used as well. Okay, so the first thing that we do is we solve each power, and then we add or subtract from left to right. Okay, so again, we always do it from left to right. And again, when we're showing our work, we're always showing every step that we do, each step in order. So in this case here, we have 3 powers. We have 4 to the power of 3, 3 to the power of 4, and 2 to the power of 3. Okay, and we can then solve for them. So the first one there, 4 to the power of 3 is 64. All right, just going to redo this here. Apologies. Okay, so 64. 3 to the power of 4, well, we already did that one up here, so we can just use that value, 81. And 2 to the power of 3 is 8. So again, we have now just solved each one of our powers. And we're replacing the power with its value in standard form in the equation. Okay, so we replace each power with its value in standard form in the equation. Now, we have 2 more steps to do here. First, we need to subtract. So I need to see you subtract. Okay, what is that value, or what is the answer to this subtraction statement? Well, 64 minus 81 is going to give us negative 17. Okay, and then we are adding 8 again. Okay, so we replaced the 64 minus 81. That's our next operation that we're doing, where we replace that with the answer, and then we added on the rest of it. So we're adding 8, which is the rest of that. Negative 17 plus 8 is the same as negative 9. So our final answer here is negative 9. Again, show your work by showing your powers in standard form, and then show the rest of your operations as to what you have done. Now, to put it into maybe a little bit more or formal terms here, I want to let you know that when we're using powers, what you might have noticed, okay, the numbers can get really big, and they can be a challenge to solve for. Okay, especially if we're doing things using mental math or just on paper or pencil. Okay, so for this lesson here, when we're doing powers, when we have stuff bigger than squared, okay, when we have stuff bigger than squared, or at least bigger than our perfect squares that we looked at earlier, okay, you may use a calculator, okay, to solve the powers and operations. Okay. Even if you don't use a calculator, you must show, and when you're using a calculator for sure, you must show the answer to each operation. Okay, so you must show the answer to each operation as shown in the examples. So you'll notice here I showed the answer to every single one of my powers, all three answers. Then I showed the answer of the first step, that's subtracting 81, and then I showed the answer of the next step, so adding 8 to that answer. So make sure that you're showing your answer to every single one. Now, on your assignment, as well as your weekly progress check or any assessment that we do, the answer alone is not acceptable. Okay, as the solution. The solution that you are giving me is your work. Okay, your answer is just part of it. The work is what I am really checking.